Hey, welcome to The Explainer. Today, we're diving into a seriously cool math technique that takes confusing, messy problems and turns them into simple pictures you can solve just by looking at them. Let's jump right in.
Okay, so let's set the stage. We've all been there staring at an algebraic inequality with a bunch of different parts. It's so easy to get tangled up in all the plus and minus signs and just get completely lost. I mean, take a look at this. Sure, you can probably factor it, but then what? How do you figure out for which values of x this entire thing is actually greater than 0? It's not as straightforward as a simple equal sign, is it? This is the exact kind of headache we're going to solve today, and we're going to do it elegantly.
Now, before we get to the really cool visual method, we need to lay down the groundwork. For pretty much any inequality problem, it all boils down to two golden rules. If you can master these, all the complicated stuff suddenly becomes way, way easier.
The first rule is super intuitive. It's probably something you already know. You can add or subtract whatever you want from both sides of an inequality. And that sign, the greater than or less than symbol, it stays exactly the same. Easy enough.
All right, now for golden rule number 2. And listen up, because this is the real game changer. It's the one that trips almost everyone up. If you multiply by a positive number, no problem, the sign stays put. But the second you multiply or divide by a negative number, you must flip the sign. Greater than becomes less than. As you can see, that one little flip makes all the difference. This detail is absolutely critical. Okay, so with those two rules locked in our back pocket, we can finally bring out the hero of today's explainer, the wavy curve method. This is our ultimate weapon, a technique that just cuts right through all that algebraic complexity.
So what the heck is it? Well, think of the wavy curve method, or WCM, as creating a visual sign map. It shows you exactly where an expression is positive and where it's negative. It lets you skip all the tedious guesswork of plugging in a million different numbers and instead lets you just see the answer.
And believe it or not, this whole powerful method is just a simple 6-step recipe. First, you get 0 on one side. Step 2, you factor everything down. 3, you find the roots, the numbers that make each factor 0. 4, you just pop those roots onto a number line. Now here comes the magic. Step 5, you always start with a plus sign on the far right. And then for step 6, you just snake your way back to the left, alternating the sign, plus, minus, every single time you cross a root. It works because crossing just one of those roots is the only thing that can flip the sign of the whole expression. Okay, Siri is great, but let's put this thing to the test with a tougher example. This one's got a fraction, which you'll see adds a fun little twist to the problem. We're looking for where this whole thing is greater than or equal to 0. Let's just follow the recipe. The roots from the top are -1 and 2. The root from the bottom is -3. We plot those 3 points on our line. We start way over on the right with a plus, and we just work our way back. Plus, minus, plus, minus. Our problem asked for greater than or equal to 0, so we just need to scoop up the sections with the plus sign. Simple, but hold on, not so fast. We've got to talk about that fraction. This brings us to a cardinal, unbreakable rule in math. You can never, ever divide by 0. So what does that mean for us? It means that root we got from the denominator, -3, is a forbidden value. It can never, ever be part of our final answer. And this leads us to a super handy visual trick, using dark versus hollow circles on our number line. Look at this table. If the inequality is a strict greater than or less than, all the roots are excluded, so they all get a hollow circle. But if you have or equal to, the roots from the numerator are included. They get a dark filled-in circle. But, and this is the key, the roots from the denominator are always excluded. They always get a hollow circle, no matter what.
Okay, you've got the basics down. You're ready. Let's level up and tackle the special cases, the stuff that can really throw you for a loop if you're not ready for it. This is the boss level.
So far, we've just been happily alternating our signs, plus, minus, plus, minus. But what happens if one of your factors is squared, or raised to the 4th power, or any even power? Does that change things? Oh yeah, it absolutely does. This is what we call the even power rule. Just think about it for a second. A factor that's squared, like x minus 4 squared, is always going to be positive or 0, right? it can never be negative. So when our wavy curve gets to that root, the overall sign of the expression doesn't change. Instead of crossing the line from positive to negative, the wave just bounces off it. If it was positive before, it hits the root and stays positive. And you have got to burn this rule into your brain. This chart shows the most common errors people make with this method. And look what's at the top. Forgetting the even power bounce is by far the biggest trap. People get into that rhythm of alternating signs and they forget to check. Don't let that be you.
All right, one last pro tip to make you a true master. If you see a common factor on the top and the bottom, you can totally cancel them out to make your life easier. But, and this is a huge but, you have to make a little note to yourself. Since that factor started in the denominator, its root is still a forbidden value. In this case, x still can't equal -2. It's a hidden trap you have to account for in your final answer.
And that's it. By combining these rules, the sign flip, the denominator rule, and the even power bounce, you have just mastered a method that can solve over 90% of all the polynomial inequalities you will ever see in your life. That is a serious upgrade to your problem-solving toolkit. So let's just zoom out for a second. Why is this method so cool? Why does it even matter? What's the real big picture takeaway here? The wavy curve method isn't just some random procedure to memorize. It's a perfect example of a deep problem-solving principle. Taking something abstract and confusing and full of symbols and turning it into a simple visual story. That sign map tells you the answer in a way that pure algebra just hides. And that is the key to real understanding, which really leaves us with a final question to think about. What other problems, maybe in math, maybe in science, or heck, even in your day-to-day life, are just an algebraic mess right now, waiting for you to find the right picture, the right visual that suddenly makes the entire solution crystal clear?